What up, and good morning to all my wannabe coders. My name is Dayton, and this is Applied Visual Design Part 5. Let's go. Okay. First and foremost, I just want to say thank you to all my subscribers, especially Mike Warrior 52. I read your comment, man. I truly appreciate it. And yes, I am going to keep going, and I am going to keep making these videos, man. And you do too. I checked out your channel. Everyone check out his Twitch, Mike Warrior 52. All right, let's go. So we are doing freecodecamp.org. If you're following along, go to responsive web design certification. We've already done basic HTML and HTML5, basic CSS, and now we're moving on to applied visual design. Scroll all the way down. This is going to be a short one too, because I think there's only like 5 lessons left. All right, so click on animate multiple elements at variable rates, and let's go. All right, animate multiple elements at variable rates. In the previous challenge, you change the animation rates for 2 similarly animated elements by altering their keyframes rules. You can achieve the same goal by manipulating the animation duration of multiple elements. In the animation running in the code editor, there are 3 stars in the sky that twinkle at the same rate on a continuous loop. Right here. To make them twinkle at different rates, you can set the animation duration property to different values for each element. Okay. Set the animation duration of the elements with the classes star1, star2, and star3 to 1 second, 0.9 seconds, and 1.1 seconds respectively. Okay, so let's see, star1, star2, star3. So they're selected right here. Sorry, folks, I'm still a little congested, still getting over the whatever sickness I had last week. So excuse me as I clear my throat. Okay. So scroll down here. The animation duration property for the star with the class star1 should remain at 1 second. Okay. Animation duration property for the star with the class star2 should be 0.9 seconds. So let's go 0.9. Okay, got a little difference in twinkle. The animation duration property for the star with class star3 should be 1.1 seconds. So then class 3, there's 0.1. Let's see what that does. Okay, yeah, kind of looks like a little heartbeats, but I guess it's a twinkle. All right, let's run the test. Bada bing, bada boom, 92%. Let's go. Okay. Change the animation timing with keywords. In CSS animations, the animating timing function property controls how quickly an animated element changes over the duration of the animation. If the animation is a car moving from point A to point B in a given time, your animation duration, the animation timing function says how the car accelerates and decelerates over the course of the drive. Okay, that's pretty cool. Okay, so as you can see here on the far right, they're going down pretty fast and then they slow down as they get to, I guess, point B. There are a number of predefined keywords available for popular options. For example, default value is ease, which starts slow, speeds up in the middle, and then slows down again in the end. Other options include ease out, which is quick in the beginning, then slows down. Ease in, which is slow in the beginning, then speeds up at the end of linear, which applies a constant animation speed throughout. If you're familiar with like video editing, this is it's exactly the same. They use the ease in, ease out to set keyframes for doing cool stuff with video editing. All right, for the elements with ID of ball 1 and ball 2, add an animation timing function property to each and set ball 1 that's a class of ball 1 to linear, and then class of ball 2 to ease out. Notice the difference between how the elements move during the animation but end together, since they share the same animation duration of 2 seconds. Okay. Animation duration of 2 seconds. So I'm guessing it wants us to like split these up. Let's see. The value of the animation timing function property for the element with the ID ball 1 should be linear. Animation timing function should be linear. So do we just add it right here for ball 1? Let me add it right here. Huh. So let's go copy this animation timing function. Let's see if this works. And then it should be, what did it say? For ball 1, should be linear. Okay, check that out. And then for ball 2, right here, let's copy paste, and this should be ease out. Okay, so check that out. It's very subtle, but you can see it. Let's run the test. Bam! Let's go. All right. There's a lot to read right here. Learn how Bezier curves work. The last challenge introduced the animation timing function property and a few keywords that change the speed of an animation over its duration. CSS offers an option other than keywords that provides even finer control over the animation, over how the animation plays out through the use of Bezier curves. In CSS animation, Bezier curves are used with the cubic Bezier function. The shape of the curve represents how the animation plays out. The curve lives on a 1x1 coordinate system. The axis of the coordinate system is the duration of the animation. Think of it as a time scale. And the y-axis is the change in the animation. The cubic Bezier function consists of 4 main points that sets on this 1x1 grid: P0, P1, P2, P3, P0, and P3. Okay, are set for you. They are the beginning of the endpoints, which are always located respectively at the origin, 0, 0, and 1, 1. You set the X and Y values for the other points, and where you place them in the grid dictates the shape of the curve for the animation to follow. This is done in CSS by declaring the X and Y values of the P1 and P2 anchor points in the form X1, Y1, X2, Y2. Pulling it all together, here's an example of a Bezier curve in CSS code. Bezier curve, bam. In the example above, the X and Y values are equivalent for each point, which if you remember from geometry class, results in a line that extends from the origin to point 1, 1. This animation is a linear change of an element during the length of an animation and is the same as using linear keyword. In other words, it changes at constant speed. For the element with the ID ball 1, change the value of the animation timing function property from linear to its equivalent cubic Bezier function value. Use the point values given in the example above. The value of the animation timing function property for the element with the ID ball 1 should be linear equivalent cubic Bezier function. Okay, so should be the equivalent. So I'm guessing I just copy and paste this, see what happens. Right there. And boom. Did anything happen? I don't know if anything happened. Well, it's the equivalent, so I don't think anything should happen. The value of the animation timing function property for the element with the ID ball 2 should not change. Okay, let's run that test, see what happens. Whoa. Okay. Well, let's go. Use a Bezier curve to move a graphic Sorry, my son just woke up. He's running around. All right. Use a Bezier curve to move a graphic. A previous challenge discussed the ease out keyword that describes an animation change that speeds up first and then slows down at the end of the animation. On the right, the difference between the ease out keyword for the blue element and linear keyword for the red element is demonstrated. Similar animation progressions to the ease out keyword can be achieved by using a custom cubic Bezier curve function. In general, changing the P1 and P2 anchor points drives the creation of different Bezier curves, which controls how the animation progresses through time. Here's an example of a Bezier curve using values to mimic the ease out style. Okay. 0, 0, 0.581. Remember that all cubic... Hold on, I gotta blow my nose. My nose is running. All right, folks, I'm back. Okay. Where did I leave off? I believe it's right here. Remember that all cubic Bezier functions start with P0 at 0, 0 and end with P3 at 1, 1. In this example, the curve moves faster through the y-axis, starts at 0, goes to P1 y value of 0, then goes to P2 y value of 1. Then it moves through the x-axis as to start 0 to start, and then 0 for P1 up to 0.58 for P2. As a result, the change in the animated element progresses faster than the time of the animation for that segment. Towards the end of the curve, the relationship between the change in x and y values reverses. The y value moves from 1 to 1, no change, and the x value moves from 0.58 to 1, making the animation changes progress slower compared to the animation duration. Okay. A little confusing, but let's go. To see the effect of the Bezier curve in action, change the animation timing function of the element with the ID red to cubic Bezier function with x1, y1, x2, y2. Values set respectively to 0, 0, 0.58, 1. This will make both elements progress through the animation similarly. Okay, so right now the blue's going a little faster, so... The value of the animation timing function property of the element with the ID red should be cubic Bezier function with x1, y1, x2, y2. Values set respectively to 0, 0, 0.58, and 1. Okay, so we got... animation timing function for red. Cubic Bezier. So we'll get rid of this. We'll go cubic Bezier. Man, hopefully I'm saying that right. Correct me in the comments if I'm not. Okay. And then what is this? It wants 0, 0, oops, 0.58, and then 1. Okay. Now they're moving at the same rate. Check that out. The element with ID red should no longer have the animation timing function property of linear. Okay, where's red? Yeah, no longer has the animation timing function of linear. The value of the animation timing function property for the element with ID blue should not change. Right, okay, boom, we're good. All right, folks, we almost done. Make motion more natural using a Bezier curve. This challenge animates an element to replicate the movement of a ball being juggled. Prior challenges cover the linear and ease out. Cubic Bezier curves, however, neither depicts the juggling movement accurately. You need to customize a Bezier curve for this. The animation timing function automatically loops at every keyframe when the animation iteration count is set to infinite. Since there is a keyframe rule set in the middle of the animation duration at 50%, it results in 2 identical animation progressions at the upward and downward movement of the ball. Okay. The following cubic Bezier curves stimulate a juggling movement. Okay. Notice that the value of y2 is larger than 1. Although the cubic Bezier curve is mapped on a 1-by-1 coordinate system, it can only accept x values from 0 to 1. The y value can be set to numbers larger than 1. This results in bouncing movement that is ideal for simulating the juggling ball. Change value of the animation timing function of the element with the ID green to cubic Bezier function 1, 1, 2, 2 values set respectively to all these numbers right here. I'm not going to say them. All right. The value of the animation timing function property for the element with the ID green should be cubic Bezier function with x1, y1, x2, y2 values as specified. Okay. So ID green right here. And then this is the animation timing function, cubic Bezier. So we gotta change this, but this simulates the juggling movement. But I want to set these. So I'm just gonna copy, and then paste right here. And let's see what happens. Oh yeah, looks like it's juggling. Check that out. Run it. And we are done, folks. And do not forget to donate. This is a free tool. They probably spent a lot of time and money creating it. All right, so now we have completed basic HTML5, basic CSS, and applied visual design. All right, folks, so that concludes applied visual design. Let's do a quick recap of everything we just learned. We made, pretty much we just learned how to animate objects in CSS without using any JavaScript whatsoever, which is actually pretty cool. So we learned how to make a motion more natural using a Bezier curve. We use a Bezier curve to move a graphic. We learned how to use Bezier. We learned how Bezier curves work. We learned how to change animation timing with keywords. And we learned how to animate multiple elements at variable rates. All right, folks. So, congratulations. Thank you for following along. And tomorrow we will start on applied accessibility. And then next week, don't forget, we are going to start our projects. All right. So, thank you for watching. Thank you for subscribing. Don't forget to like, comment below. I read everything and I reply to everyone. So, yeah, folks, until tomorrow, peace.